All right, now let's take a look at finding the complex zeros of a polynomial function and writing in factored form. So our tools, for the time being at least, are the same. Can we find any real zeros? Might there be rational zeros? If so, then those would be of the form factors of the constant 34 over factors of the lead coefficient 3. And for 34, we've only got 1 in 34 itself and 2 in 17. 3 being a prime number, we've only got 1 in 3. So look at pairing up each numerator with each denominator. Reduce if you can. And don't repeat anything. None of the stuff over 3 reduces, though, and so no repetition of something we already wrote over here. Now let's see what else here. Largest absolute value there is of the positive negative 34. So I'm going to graph. Let's see here. We've got y equals 3x cubed and then minus 22x squared followed by plus 35x and the x got erased, so plus 34. Probably more than I need, but I'm going to view from negative 35 to positive 35 in the x direction. Look for an x-intercept when y is 0, so I don't need to see too much in the y direction here. And it looks like there's something going on real close to the y-axis. Let's double check that I have the equation correct, by the way. 3x cubed minus 22x squared plus 35x plus 34. So yeah, my point of view was a lot wider than I needed. Seems like we have an answer real close to the y-axis, something real close to x equals 0 right there, maybe between negative 1 and 0, and that would mean we'd be dealing with a proper fraction, so it can only be one of these two. Well, actually, there's 4 there because of the positive negative. If we check it negative 1/3, trace and negative 1/3, that does not seem to do the job. But then negative 2/3. Let's confirm that using synthetic division. So let's see here, negative 2/3. Luckily, we don't have any missing powers of x here. Bring down the 3. 3 times negative 2/3 is going to get rid of that denominator, give us negative 2. Add negative 24. Watch those signs. Luckily, that's a multiple of 3. 3 goes into that, negative 8 times negative 2, positive 16. I'm going to give that a double check real quick. Negative 2/3, parentheses around the fraction, times negative 24. Yes, that is positive 16. That adds up to 51. 3 goes into 51, 17 times. And we have times negative 2, negative 34. So that tells me 2 things. Negative 2/3 is a rational 0, therefore a real 0. Of this equation, of this polynomial function. And we're also getting x plus 2/3. That quantity, that's a factor, as is 3x squared minus 24x plus 51. We've divided a cubic, degree 3, by a linear, degree 1, and so those coefficients must start off in front of x squared, a quadratic. 3x squared minus 24x plus 51. I want you to further notice that all of these coefficients are multiples of 3. If I factor that 3 out, that would deal with this problem of a fraction. And that will let me, when I distribute, I'll see f of x equals 3x plus 2. That's a nicer way to write that factor. As for the quadratic factor that remains, that is not going to be factorable. You're not going to find a pair of numbers with a product of positive 17 that also adds up to negative 8. So you could either use the quadratic formula, or notice that that's almost the same as x squared minus 8x plus 16. Negative 17 plus 16 is negative 1. That, if we take half of 8, that's negative 4. And negative 4, all of that squared, is positive 16. So I've added that to both sides. That negative 4 I was just talking about shows up when I rewrite that perfect square trinomial as a binomial squared. Take the square root of both sides. Don't forget your plus or minus. Square root of negative 1 is I. And then isolate x. So we have the negative 2/3 and 2 complex solutions, all of our zeros. The directions also asked us to write a factorization. So same thing, that x equals negative 2/3 was a 0 and x plus 2/3 was a factor. Use that same relation to write the factorization using the complex numbers. We could write this as either the 3 times the quantity x plus 2/3, or the little bit nicer version here. And then you'd have x minus all of 4 minus I, and x minus all of 4 plus I. Let me check something here real quick. Okay, so for those of you that are taking a class from me, it's going to require you to simplify a little bit in the online homework system. So we'll have to distribute that's going to give us the f of x is equal to this. That's all that I've got for now. As always, I hope this has helped. And if it has, please like the videos, subscribe to the channel. And if you know of anybody else working on similar stuff, then share this with them if they're having some difficulties and are looking for resources for help. Take care. I'll see you in the next one.